In this video, you will learn how to take any sprite sheet and turn it into a fully fledged sprite animation using the HTML Canvas API without the need of any frameworks. Before we begin, it is worth mentioning that the sprites you are currently seeing have been chosen for demonstrative purposes only. The concepts covered in this video will work for any kind of sprite sheet, so long as the sprites are positioned properly, and we will talk about how to position the sprites correctly later on. So here we are in an empty project folder. I've already prepared the sprite sheet that we will be using in this tutorial beforehand. You can of course use your own sprites, but the link to the sprite sheet that we will be using in this tutorial will be posted in the description box below if you want to use the same sprites as me. As you can see, there are 14 sprites in total, arranged in 7 columns and 2 rows. Both rows are dedicated to the animation of a particular repeating action. In this case, that would be this Sub-Zero character walking. The only difference between the 2 rows is that they are walking in different directions. So the top one is walking towards the right, but in the bottom one is walking towards the left. Also, pay attention to how the sprites are spaced out between each other. If you do decide to use your own sprite sheet, then it is very important that you get the spacing correct before you begin the development process, otherwise your canvas sprite animation will not work as intended. The actual dimensions of the sprite sheet are unimportant. Theoretically, they could be whatever dimensions that you want them to be. What is important is how you position the individual sprites within the sprite sheet itself. You want to divide the sprite sheet up into equal columns. The size of these columns will of course be dependent on both the width of the sprite sheet and the highest number of sprites that you have in a single row on the sprite sheet. The size of the sprites themselves do not need to be uniform. The only requirement for them is that they are placed in the correct sequence in relation to the animation that is being conveyed on the row, and most importantly, they fit within their own column on the sprite sheet. In this example here, the highest number of sprites that we have on a single row is 7. Therefore, we divide up our sprite sheet into 7 columns of equal proportion, 1 column for each sprite. The other requirement for your sprite sheet that is of extreme importance is keeping the vertical space between each row of sprites double the space between the vertical edges of the sprite sheet and the top and bottom rows of sprites. In this example here, we only have 2 rows of sprites, but the same principle applies. As you can see, there is only 1 grid track between the top and bottom edges of the images, and the row of sprites closest to those edges. However, this middle gap here, the one between the 2 rows of sprites, it is twice as large and takes up 2 grid tracks. We do this to make sure that every row of sprites has equal space, both top and bottom. We will soon be splitting up our sprite sheet into individual rows. In this case, we will only have 1 horizontal split right in the middle, as we only have 2 rows. Now, once we have made this split, you can see that both of the rows have equal space, both to the top and to the bottom. This is regardless of whether the row is closest to the top or bottom of the sprite sheet or not. Now that you know the correct layout for your sprite sheet, you should have your sprite sheet prepared like I have before you continue any further with this tutorial. So as you can see, I've already got the image there. I'm just going to create the HTML file now. I will then use the VS Code ! code snippet to set up the boilerplate markup. I will then link to a style sheet and a JavaScript file at the bottom of the body tag, both of which have yet to be created. Next, I will create the canvas element inside of the body tag. The only attribute that I give it is an ID. I don't assign it any dimensions here because I want this canvas to take up the entirety of the viewport. The size of this varies from user to user, and so it needs to be configured later on when we get to the JavaScript file. Before I could go on to that, however, I will first create the style sheet. I will fill it with these properties. I have written these properties in particular to prevent the canvas from taking up more space in the viewport than it needs to. If any elements have either padding or margin to it, and we want to assign the canvas to the entire width and height of the viewport, as we do, then those margin and padding values will affect our canvas in a way that makes it bigger than the viewport itself. In response to this, our browser will add a scrolling bar to the web page, and we don't want this scroll bar, so we write out this styling to get rid of any margin and padding that may exist in the document. Now we can create the JavaScript file, the file that we will be spending the majority of our time in. Since we are working with the Canvas API, it is essential that we first extract the context from the canvas. Without doing this, we would be completely unable to interact with the API. Then we will set the canvas width and height to match the viewport's width and height respectively. The new canvas dimensions will now obviously vary based off of whatever size the viewport was when the client loaded the web page. Since both of these properties come from the window object, we don't actually need to write out the window object to read their values. This is normal behavior for JavaScript on all properties and methods from the window object. We will now need to create an image object. It will hold our sprite sheet. Since images are loaded asynchronously in JavaScript, we will create this method to prevent our canvas element from loading before our image element, preventing us from drawing our image onto our canvas. This numOfImages variable holds the number of images that we will have in our JavaScript file. In our case, we will only have one image. Every time the function is called, it will pre-comment this numOfImages variable, meaning that its value actually gets decreased by 1 when this if condition is evaluated. If this newly decreased numOfImages is found to be less than 0, which in our case it will be the first time the function is run, then we could start drawing things onto our canvas. This will be done below the return keyword that prevents us from progressing any further on in the function. We assign this function to the onload property of our sprite sheet image. We want the function to be called as soon as our image has been successfully loaded asynchronously. Everything that we want drawn to the canvas will be done so in this animate function. That is because it will be repeatedly invoked on every new canvas frame, as we have passed it into this requestAnimateFrame method, which is a method from the window object, hence why we can write it out on its own. We also write out this clearRect method, which wipes the contents of the previous canvas frame, allowing us to draw new content onto the canvas without it interfering with the contents of the previous frame. Then we will render out the image onto the canvas. This will actually be the only thing that needs to be rendered onto the canvas in order for our animation to work. We set its height and width to match the original sprite sheet image, and we set its position to be the canvas origin, which is always its top left corner. Finally, we will call this animate function after the return keyword in the loadImages function. This means that we won't even attempt to draw the image onto the canvas until the image has been completely loaded asynchronously. And so now we can look at our HTML file. I use LiveServer, which is a VS Code extension. And as you can see, we have our sprite sheet being drawn to the canvas with the values that we wanted it to have. But obviously, just getting the sprite sheet drawn onto the canvas is not good enough. We want an actual animation to be played. Therefore, the first thing that we will do is work out the dimensions of an individual sprite from our sprite sheet. The cols and rows variable should match with the sprite sheet that we want to use. Since we have set up our sprite sheet properly, following the guidelines previously mentioned, we can simply divide the width by the number of cols that we have to get the width of an individual sprite, and do the same to get the height of an individual sprite, just with the rows and height instead. We will then create these two variables. They will help us keep track of which sprite we should currently be showing. The value of the total frames variable will remain unchanged. It is there to keep track of the number of sprites present in the particular animation sequence that we want to show. In our case, both rows of sprites will have 7 sprites each. If their numbers do not match up, then we would need to change this variable's value based on which row of sprites that we want to animate. The value of this current frame variable will change, however. We will increment it to get our application to show the next sprite along in the animation sequence. Its use will become clearer later on. These variables will enable us to cut out and display a specific sprite from our sprite sheet. We will increase these variables by the values of sprite width or sprite height respectively to ensure that each sprite is being displayed in its entirety and is not being cropped out in any way. Now, currently, we are only passing in 5 arguments into our drawImage function. There is actually a total of 9 possible arguments that we can pass into this drawImage function. We will use every single one of them for the purpose of this tutorial. This comment tells us the order of the arguments and what they mean. The new arguments can be found from source X to source height. These enable us to crop out areas from our source image that we have passed in as the first argument. Source X and source Y configure the starting point of the crop, and the source width and source height configure the new dimensions of the cropped image. Once we have cropped our source image, we can then use the destination arguments as normal to position the cropped image as if we had only passed in that cropped image as the source image in the first place. Now that you are aware of what these arguments do, we will pass in these 9 values into the function in the specific order. As you can see, we now only have one sprite being displayed in the canvas origin. We have cropped out the first sprite and set the dimension of this cropped sprite to be the canvas's origin, and its dimensions to match the dimensions of a singular sprite in our sprite sheet. It's important that we do this to prevent our sprite from being stretched further than its normal dimensions. To display a new sprite, one along from the previous sprite, in the animation sequence on a new canvas frame, we will use this modulo operator to get the remainder of the current frame divided by the total frames, which in our case is 7. At the moment, the value returned from this operation will be 0, because current frame is currently 0, and nothing goes into 0, so therefore there would be no remainder. When we increment current frames equal 1, however, which we haven't done yet, the value returned will be 1. This is because 7, the value of total frame, does not go into 1 as it is a larger number. Therefore, the entire number, 1, will be left over as the remainder. The value of current frame being left over as the remainder will remain true until it is incremented to be the value of 7. When this happens, the value returned from the operation will be 0 again, because 0 divided by 0 is 1, and therefore there is no remainder. It is at this point when the animation cycle restarts itself. Now you might think that if we were to use this method, then we would miss out on a sprite and only display 6 sprites in total, as the highest value that current frame can be is 6, and there are 7 sprites in a row. This is not the case, however, because the first sprite in the sequence is represented by current frame being 0, so therefore there will actually be 7 sprites being displayed, because the 7th sprite is represented by the current frame value being 6. So all of this is well and good, but none of the values that we have just worked with are used to draw the image onto the canvas. To get the next sprite in the sequence to be displayed, we will assign source x to the value of current frame multiplied by the width of an individual sprite. So if current frame is 2, then we will skip the first 2 sprites and crop the third sprite out from the sequence. Lastly, we will increment current frame so that a new sprite can be displayed on a new canvas frame, and then we will look at what we have created. So we have gotten the sprite moving, but it is moving far too fast. This is because we are invoking the animate function 60 times a second, meaning there are 60 new sprites being displayed every second. Our sprite sheet was not designed for this speed, which is why the animation looks way too fast. The solution is to create a variable that will count the number of times that the animate function has been invoked. Then we will only increase the value of current frame once 10 canvas frames have been elapsed. This means that the number of sprites being displayed in a second has gone from 60 to just 6. When this does happen and 10 frames have elapsed, we will reset the value of frames drawn so that we can wait for another 10 frames to pass until we increment current frames again. Now you can see our animation is moving in a more palatable speed. It does look a bit small, however, and it would be nice if we could position it in the exact center of the page, and we have created a separate function to do that. We create this variable because we are going to increase the sprite size by a scale factor of 4. Then we will work out the center point of the viewport and subtract its values by half of the sprite's width and height, multiplied by the scale factor respectively. This will put our destination origin back in upwards so that the middle of the sprite is positioned in the middle of the viewport and not the top left corner of the sprite. Finally, we will move our entire canvas to the center coordinate and upscale it both horizontally and vertically by our scale factor. Now, it is extremely important that we save the canvas's context before the function is called, and then restore the canvas's context before it was upscaled after the image has been drawn to the canvas. If we do not do this, then the canvas will continue to be scaled up in multiples of 4 each time the animate function is called. And so now we can see our finished result. Okay, so our sprites look a bit blurry for my liking. This is because by default images are upscaled with an algorithm that interpolates the pixels to make them not look like a jangled mess when they are upscaled. And now this is fine for realistic photos, but it does not work well for pixel art like this, where the hard edges of the pixels are what actually makes the sprites look good. We can disable this algorithm by doing the following. Now we write it out twice for compatibility reasons, so it will work for older browsers. Now if you need this code, then I'll post the link to this project's entire code in the description box below, so you can just copy it from there. Great, so our image actually looks good for a change. Now we could leave the tutorial at that, but I have yet to make use of the sprite sheet second row, where the character is walking in the opposite direction. I want to be able to animate this other row when I press the left arrow key. I will therefore create the following event listener. We will move the starting position of where we cropped the source image on the y-axis downwards, so that it is the sprites on the second row that are shown, not the first. We multiply the value of sprite height by 1 to choose sprites from the second row. If you wanted sprites in the first row, then 0 would be our multiplier, not 1, because we don't need any crop on the y-axis to get sprites from the top row, and therefore, you times 0 by anything, the answer is 0, and therefore there would be no crop in that case. But in this case there is, and source y will now be the value of sprite height just on itself, meaning that it skips the height of the first row of sprites and only shows the sprites on the second row. We will use this knowledge to display the animation conveyed on the first row in the sprite sheet when the user presses on the right arrow key again. Great, so animation is working perfectly, just how we want it. We can move him in both directions and it's looking good. So that just about wraps things up for this tutorial. I hope that you enjoyed it and learned something useful from it. If you have any questions, then please don't hesitate to post them down in the comments box below. I would love to hear from you and will answer any of your questions to the best of my ability. You would also be doing me a huge favour if you considered liking and subscribing. Any support from you would be greatly appreciated. Now I hope you have a great day and peace out.